Hello, good morning, everybody. I hope you are all doing well. Everything is good with you. So, last time we started a new topic that was about geometry. Precisely, it was about triangles. All right. So, we mentioned the relationship between the angles inside a triangle, and we've said that the sum of the angles inside a triangle is equal to 180 degrees. Alright, today we will continue in the same topic, but we are going to discover a new relationship in the triangle, but this time with a different angle that is called exterior angle. Now, what is the exterior angle and what's its relationship with the other angles inside the triangle? That's what I'm going to show you now. Now guys, suppose in my triangle I make an extension line here, okay? Now the angles 1 and 2 and 3, they are called interior angles, means they are inside my triangle. The angle 4, which is here, is an exterior angle. Now my question is, what is the relationship between the angle 4 and the angle 3? Of course, we know that this is a straight angle. That means 180 degrees. So 3 and 4 can form a straight angle that is 180 degrees. Now let's write this equation. We know that the sum of the angles that are inside my triangle is equal to 180. Means what? Measure of A plus the measure of 2 plus the measure of 3. Okay, that is 180. We also said that the angle 3 plus the angle 4 is 180. 3 plus 4 is 180. So this side is 180. It is equal to this side that is 180. Look at this equation, guys. Now, what can I say about this equation? Which one is a simplified equation of this? What I'm going to do here, look carefully. I'm going to subtract measure of 3 from both sides of my equation. Okay, so I will have measure of 1 plus measure of 2 equals to measure of 4. So this is the right equation. Now let's complete this theorem. We say that the exterior angle, that is 4, is equal to the sum of its remote interior. These, we call them remote interior, means they are interior and they are remote. Remote means they are far from the angle 4. 3 is not remote interior, it's adjacent interior. So we said 4 is equal to the sum of 1 and 2. 1 and 2 are called remote interior angles. Okay, very good. Now let's draw the theorem. The exterior angle theorem says that the measure of an exterior angle, for example this one, is equal to the sum of its remote interior angles. Again, what are the remote interior angles? They are the angles that are not next to the exterior angle. So angle A and B are remote interior angles for the angle 52 degrees. Okay, now let's solve together this example. I have this exterior angle that is 52 degrees. Okay, I know that A measures to 4y minus 4 degrees and B measures to 3y degrees. Now I want to find the expression that expresses the exterior angle theorem. What is the expression? Okay, by looking at these equations, which one describes the exterior angle theorem? Of course, we know the measure of the angle ACD, which is 52 degrees here, is equal to the measure of the angle A plus the measure of the angle B. Alright, so this is the correct one. A plus B gives me 52 degrees. Okay, Now, understood how to draw the exterior angle, of course, and you understood what the external angle is. It's basically by extending one of your sides of the triangle, then the resultant angle is called the exterior angle. Now, the question says, how many total exterior angles does a triangle have? Of course, the triangle doesn't have one exterior angle, but it can have more than one. Let's find them. So what we are going to do, we are going to extend this side like this, and it makes an angle here. So it is an exterior angle. If we extend this side, it makes an exterior angle from here, which is angle 2. Okay? 3, of course, is an exterior angle. 4 as well by extending this side to this way, and it makes an angle here that is 4, which is an exterior angle. Also, by extending this side downwards, you will have an angle that is exterior. Finally, extending this side to the left gives you an exterior angle that is shown here as 6. So in total, we have 1, 2, 3, 4, 5, 6 exterior angle in one triangle. Okay, now let's all together solve this example. I am given this triangle we have shown already previously, and you have this angle that is 52. This is 4y minus 4, which is A, and B measures to 3y. Now I want to find the measure of the angle A and the angle B. What am I going to do here is to set up my equation. What is it again? It says that the sum of the remote interior angles is equal to the measure of the exterior angle. I'm going to do the same thing here. My exterior angle is ACD, okay? It is equal to the sum of its remote interior angles. Can C be considered as remote interior angle? The answer is no, of course. Why? Because we said remote interior angles are far from your exterior angles, so they are A and B. So the angle ACD equals to the sum of its remote interior angles that are A and B. So the measure of A plus the measure of B equals to the measure of ACD. Okay? Now I'm going to substitute each angle here by its value. Of course, the angle ACD measures to 52, so ACD here is 52 degrees. Now, what is the measure of the angle A? Of course, it's 4y minus 4 degrees. But about B, it measures to 3y degrees as shown here. All right, now you are going to simplify your equation. Okay, so this is what? You just open the bracket, so 4y minus 4 degrees plus 3y degrees equals to 52 degrees. You add 4y with 3y, that is 7y, minus 4 equals to 52. Okay, this is a simplified equation. Now, you will add 4 for both sides. Minus 4 plus 4 is 0, so this side gives you 7y degrees. 52 plus 4 is 56 degrees. So 7y is equal to 56. Then you divide both sides of your equation by 7. So 7 cancels out with 7, and you will have y equals to 8, or 8 degrees. Okay, am I done? No, not yet. Why? Because the question asks for what? For the measure of A and B. Here I just found y, so I'm in the middle of the way. Now, how can I find A and B? Very easy. I'm going to take the value of y and plug it in the measure of A and B. So the measure of A is equal to 4y minus 4. Okay. And y is equal to 8. So I'm going to replace y here by 8. So the measure of A is equal to 4 times y, that is 8 minus 4. 4 times 8 is 32, minus 4, that is 28. So the measure of A is 28. A is 28 degrees. Now what is the measure of B? We do the same thing. We take the value of y that we found here and we plug it or substitute it in y. So the measure of B is 3y, so it is 3 times 8, which is 24. So the measure of B is 24 degrees. B is 24 degrees and A is 28 degrees. Now let me add another question. If I am asked to find the angle ACB, I'm talking about this angle right here. How can I find it? Well, I have two ways. Okay. The first way, I say the measure of A plus the measure of B plus the measure of ACB, this angle, equals to 180, and I will solve the equation. That's one way. The other way, okay, I would say this total angle here is 180, okay, and I know that this angle that I'm looking for, which is ACB, plus 52 gives me 180. So my angle will be 180 minus this angle, which is 52, and gives me the exact measure of ACB. All right, now it's your turn to find the measure of the angle M and angle N. So please stop the video here. Try to solve this equation by yourself. After you finish, play to see the answer. So M should be 78 degrees. How can we find this? Easily, we say that the exterior angle is equal to the sum of the remote interior angles. Here N and M are interior angles, and they are remote from the angle MPQ, which is this one. So my equation will be 5y plus 3 plus 4y plus 8 equal to 146. You solve the equation, you find the value for y, then you plug it back here, and you will find the angle M. You plug it back here, and you find the angle N, that is 68 degrees. All right, guys, thank you so much for today's class. Take care of yourselves, and see you tomorrow. Bye.